So 2 more questions in this lesson, and this is the first one where I wanted to show you an example of changing one trig function into another trig function. So if you see this one, you notice that you've got tangent and cotangent within the same problem, and we can't do sort of the cutesy things we were doing on the last 2 on the board, right? Because we've got other addition and subtraction going on. So we've got to be a little bit more careful in how we work with the problem. In particular, we need to change this cotangent or the tangent into the other one. And because they're reciprocals, that works pretty well. So we can take tangent of theta plus 1 equals the square root of 3 plus the square root of 3. And we can rewrite cotangent as what? 1 over tangent theta, right? And so, in fact, I'll write this as square root of 3 over tangent theta. All right, so I now have a tangent theta in the denominator, no matter whether I wrote it like this or as Lauren has originally said, to write it as 1 over tangent. And I don't want to have tangent theta in the denominator and also not in the denominator at the same time. So how do I get something out of the denominator? You multiply by it, exactly. So we're going to multiply, but if we multiply by this, we've got to multiply both sides, okay? So I'm going to multiply by tangent of theta on both sides of my equation. So on the left-hand side, this becomes tangent squared of theta plus tangent of theta. On the right-hand side, I get square root of 3 tangent theta, and then what? Plus square root of 3. Yeah. Anytime I have squared functions and original functions, right, like tangent and tangent squared in the same problem, sort of should be a red flag. This is going to be factoring. I'm going to do something with factoring, and in order to factor, it means everything has to be on the same side and 0 on the other side. So that's where I'm headed next. I'm going to take this tangent squared here, and it stays put, and my tangent stays put. And then I'm going to subtract each of these to the other side. So this is going to be minus square root of 3 tangent theta, and minus square root of 3, and then equals 0. Oh, I don't have my board down, do I? That's better. All right, so this is not your typical factoring. What kind of factoring is this? Grouping. I've got 4 terms, and typically when we see 4 terms, factoring by grouping is what we're going to be seeing ourselves work with. And you can usually group them where they are first, and if that doesn't work, then we'll rearrange. But usually either grouping works. So if you're taking a look at the first grouping, what can I factor out of tangent squared theta plus tangent theta? Tangent of theta, which leaves me with what? Tangent theta plus 1. Good. What can I factor out of the second set? Negative square root 3 tangent theta minus square root 3. Yeah, and we're going to factor out a negative square root of 3 even, because they're both negative, so we might as well. And in fact, it will be more helpful if we do. I'm left with tangent theta then plus 1. And do you notice what beautiful things are happening? Not cancel, but these match, don't they? That's not a good color to use. There we go. These match. And in factoring by grouping, that's what you want. If these do not match, then you got to start again. Okay? But they do match. And in essence, what I've got now is I've got this whole expression here, and I've got this whole expression here, and the parts that they have in common are the parts in parentheses. So I'm able to factor out the part they have in parentheses, that is the part they have in common, tangent theta plus 1. And then for the first bulk of what's going on, what's left is tangent theta, right? Because I factored out the other piece. And what's left from the second piece is the square root 3. And this is what I want, right? This is the one that looks an awful lot like the one that was already given in factored form that we did on the board. Because this is in factored form, I can now take this and I can set each part of it equal to 0 and solve it. So now I have tangent theta plus 1 equals 0, and I have tangent of theta minus square root 3 equals 0. The first one then is tangent of theta equals -1. And where does tangent of theta equal -1? Second and fourth quadrant. Good. 3 pi-4 and 7 pi-4. The other one's a little bit trickier, so I've got tangent of theta equals square root of 3. I'm going to write it as square root of 3 over 1, and remember the reason that comes about, or how that comes about from a unit circle, is square root 3 over 2 and 1/2, because the over 2's would cancel out if we simplified that piece of it. And so we're wanting a y value of square root 3 over 2 and an x value of 1/2. It's the thirds one. The sixth one would be reversed if it were flipped upside down. So pi-thirds, and where else? 4 pi-thirds, yeah. It needs to be in quadrant 3 because we have the positive tangent value. So these are the two. So as you're thinking about your test, be sure that you're writing good information for yourself on that note card, right? Whatever it is that that means to you, make sure you're writing useful information to you on your note card to be used. Any questions on this one? All right, we have one more. And this is very similar to one of the ones in your homework that I said you could avoid for now. You can't avoid it after today, but you have sine of 4 theta and sine of 6 theta, and 4 theta and 6 theta are not the same. Correct? Okay. However, you have a list of identities, and one of your things in your list of identities tells you what you can do when you have sine of something minus sine of something else. They were the sum to product identities. Okay? Those sum to product identities can be used here excellently. Okay, could we use double angles here? We could, but we're still not going to get the 4 theta and the 6 theta to match, right? So that's not going to, we're going to be running our wheels in all kinds of directions if we do that. But the sum to product identities here say that this will become 2 sine of the angles subtracted. So this is 4 theta minus 6 theta over 2. And cosine of 4 theta plus 6 theta over 2. If I simplify this, and I know I'm cutting out a little bit of the thinking process here, but this would be negative theta on the first one and 5 theta on the second one if we add and then divide and whatnot. This is in factored form. Agreed?
Wouldn't it be 2 cosine? This is subtraction.
Did I write something down wrong?
That's what this sheet says.
Let me look at my sheet. Oh. Oh, cosine at the beginning and sine at the end, is that what you mean?
Yeah.
Yeah, I have them backwards, don't I? Thanks. That's even nicer in some respects because cosine of negative theta is the same as cosine of theta, right? And then you're just taking a look at each of these equal to 0. So where does cosine of theta equal 0?
Yeah, but it would be 4 theta plus 6 theta.
Okay, hang on. Maybe I misunderstood what you were saying. Oh, I'm just using them in a back. I used them backwards, didn't I?
Yeah.
Okay, but okay.
You gotta do A plus B.
Yeah. Okay. So can I just change it back to what I had before and realize that I've got them in the opposite order? Because this is multiplication, guys, right? So it doesn't matter what order I put them in. So what I had originally was okay, wasn't it?
Yeah.
Yeah. It's just backwards of what it's written on your book in your notes as. I think that I wrote them backwards from what your book had them originally in your notes or whatnot. Okay. Does this work okay? It's just that it's backwards. I'm not entirely sure you guys are with me. Let me do this.